Our story begins not with Earth, but with the stars. Every atom in your body, every rock and drop of water, was once part of a vast cloud of gas and dust in space. Over 4.6 billion years, this cosmic dust formed our home. Stars are born, live and die in spectacular explosions called supernovae, forging elements like carbon, oxygen, and iron, essential for planets and life. Our solar system, and Earth, are made from the remains of ancient stars. We are, quite literally, made of stardust. Imagine Earth's history as a single year. Humans appear only in the last minutes of December 31st. The planet's fiery formation fills the first months, a reminder of the immense journey from chaos to life. Let's travel back, before Earth existed, to the swirling cloud that was our solar system's nursery. We'll witness the violent birth of a planet, the impact that created our moon, and the cooling that allowed oceans to form. The planet's surface began to shift, and in the warm, shallow waters, something remarkable happened. Life began. This is the story of Earth, our home, and our connection to the universe. Join us as we explore how stardust became a living world. About 4.6 billion years ago, our solar system was a cold, rotating cloud of gas and dust, the solar nebula. Mostly hydrogen and helium, it was sprinkled with heavier elements from ancient stars. A nearby supernova's shockwave triggered the nebula's collapse. As it contracted, it spun faster, flattening into a disk. At the center, pressure and temperature soared, forming the proto-sun. When nuclear fusion ignited, our sun was born, flooding the disk with energy. The surrounding protoplanetary disk became the birthplace of planets. Near the sun, only metals and rocks could condense. Farther out, ices formed. This temperature gradient explains why inner planets like Earth are rocky, while outer planets are gas and ice giants. The sun's light and solar wind swept through the disk, shaping the young solar system. In this swirling chaos, the seeds of planets began to form. The solar nebula's transformation set the stage for everything to come. From this cosmic nursery, our world would soon emerge. The story of Earth's birth was about to begin. Let's see how dust became a planet. In the protoplanetary disk, planet formation began with tiny dust grains sticking together. Through accretion, these grains grew into pebbles, rocks, and then planetesimals. Hundreds of kilometers across, millions of planetesimals collided, merging into larger bodies in a chaotic cosmic demolition derby. The largest grew faster, sweeping up material in runaway accretion. In Earth's orbit, one protoplanet became dominant, the proto-Earth. Each collision kept it molten, a glowing red-hot ball of liquid rock. Heavier elements like iron and nickel sank to the center, forming Earth's core. This process, called differentiation, created a layered planet, core, mantle, and crust. Early Earth was hellish. No solid surface, no oceans, no atmosphere. Bombarded by debris, its surface was a sea of lava. Yet, this violence was essential, forging the structure of our world. The stage was set for the next dramatic event. From chaos, a planet was born. But Earth's story was about to take a colossal turn. The early solar system was crowded and dangerous. Earth shared its orbit with another large body, Theia, about the size of Mars. Their paths converged, and about 4.5 billion years ago, Theia collided with Earth in a cataclysmic impact. The energy released was unimaginable, vaporizing part of Earth's mantle and obliterating Theia. Debris formed a glowing ring around Earth, which gravity pulled together. Within thousands of years, this debris coalesced into our moon. The moon was born close to Earth, appearing enormous in the sky. This impact tilted Earth's axis, giving us seasons, and sped up its rotation. Moon rocks share Earth's chemistry, supporting this giant impact theory. The moon's gravity stabilizes Earth's tilt, creating a stable environment for life. The moon's formation was crucial to Earth's destiny. After the moon-forming impact, Earth entered the Hadean Eon, a world of fire and steam. The planet was a global magma ocean, glowing red-hot with days lasting only hours. The moon loomed large, raising massive tides in the molten rock. Outgassing from the molten surface created a thick, crushing atmosphere of water vapor, carbon dioxide, and nitrogen, no oxygen. This atmosphere trapped heat, keeping Earth molten for millions of years. Slowly, bombardment eased and the planet began to cool. The first crust formed, but it was thin and unstable, constantly recycled by volcanic activity. Volcanoes replenished the steamy atmosphere, shaping the planet's surface. This chaotic era lasted hundreds of millions of years, setting the stage for transformation. Outgassing delivered water vapor and heavy elements sank to form the core. The Hadean Eon forged Earth's layered structure. Despite the fury, Earth was preparing for its next leap, the arrival of liquid water. The world was about to change forever. As Earth cooled, surface temperatures finally dropped below water's boiling point. Water vapor condensed, and the first rain fell. Not a gentle shower, but a planet-wide deluge lasting thousands of years. Oceans literally fell from the sky, filling lowlands and merging into vast seas. Early oceans were hot, acidic, and mineral-rich, shaped by volcanic gases and carbon dioxide. Water came from outgassing and from countless comet and asteroid impacts during the late heavy bombardment. These icy bodies delivered extra water, supplementing what was released from Earth's interior. As oceans formed, the atmosphere thinned and surface pressure dropped. Oceans absorbed carbon dioxide, cooling the planet and stabilizing the climate. With stable, vast bodies of water, Earth was no longer just a ball of rock. The stage was set for life's emergence. Oceans became the cradle of the next great chapter. Water transformed Earth into a dynamic, living world. The ingredients for life were now in place. With oceans and a solid crust, Earth's surface began to move. Plate tectonics had arrived. The crust broke into plates floating on the semi-molten mantle, driven by heat from the core. Early plate tectonics was chaotic, with thin, rapidly moving plates and rampant volcanism. Where plates collided, subduction recycled crust and built volcanic mountains. Plate tectonics created continents, ocean basins, and regulated climate through the carbon cycle. Weathering and volcanic eruptions balanced carbon dioxide, acting as Earth's thermostat. This dynamic system kept Earth's climate stable for billions of years. Without plate tectonics, Earth might have become a frozen wasteland or a runaway greenhouse. The restless crust made our world habitable. With a stable crust, oceans, and a balanced climate, Earth was ready for its greatest leap life. Around 4 billion years ago, in warm, mineral-rich waters, non-living chemicals organized into self-replicating molecules, life began. Life may have started at hydrothermal vents, where chemical energy and minerals created the perfect laboratory for early cells. For billions of years, life remained simple. Single-celled organisms dominated the oceans. Then, cyanobacteria evolved photosynthesis, using sunlight to make energy and releasing oxygen as waste. Oxygen first reacted with iron in the oceans, but eventually built up in the atmosphere. The Great Oxidation Event was a catastrophe for some life, but opened the door for complex organisms. Oxygen transformed the planet, paving the way for evolution's next steps. Life's chemical miracle reshaped Earth forever. Across 4.6 billion years, Earth transformed from stardust to a living world. Fire and violence gave way to oceans, continents, and life. The moon's formation, plate tectonics, and the rise of oxygen all shaped our planet's destiny. Every step was interconnected, a chain stretching back to the stars. The carbon in our cells, the iron in our blood, the water we drink, all forged in ancient stars. We are children of the cosmos, living on a rare, precious world. This story connects us to the universe and deepens our sense of wonder. Understanding Earth's journey gives us perspective on its resilience and its fragility. We are the stewards of a world billions of years in the making. Appreciating its history is the first step to protecting its future.